Day 17 of 60, and tonight your phone buzzes at 2 a.m. Your EDR flagged a cloud VM, no GUI, no CM agent, just an SSH prompt and a sinking feeling. Somewhere on this box, a process is beaconing out to a command and control server right now, and you have to prove it using only the tools already installed. By the end of these 5 minutes, you'll read a compromised Linux host like a story, its sockets, its routes, its DNS. Let's go. First, the mental model. Every network tool reads a different layer. The kernel tracks sockets in /proc/net. The SS command parses those into human form, who's listening, who's connected. The IP command shows routing, where packets actually go. And resolvectl shows DNS, how names become addresses. An attacker can poison any one of these. Your job is to interrogate all 4 faster than they can clean up. Start with listeners, because a backdoor has to listen or call home. Run ss-tulnp. That's TCP, UDP, listening, numeric, with process. The P flag is the magic, it maps each socket to its PID and command name. You'll see SSHD on 22, fine. But here's our rogue, a process called quirkered listening on 0.0.0.0:4444. Real kernel workers never open sockets. That fake name plus that port is your first lead. Note the PID. We're going to chase it. Now flip to outbound. Run ss-tnp state established. This shows live TCP connections with foreign addresses. Pipe it through awk to pull just the remote IP, ss-tnp state established awk, print $5. Most traffic is internal, 10 to 172, 192.168. The beacon hides in plain sight as the one connection to a public IP on a weird port. There it is, an established session to 185.something on port 8443, owned by that same suspicious PID. But trust nothing during an active compromise. Attackers replace SS with a Trojanized binary that hides their own connections. So verify against the kernel directly. Read /proc/net/tcp6 and TCP. The addresses are hex, little endian, ugly, but honest. Cross-reference, for each PID in /proc, walk /proc/PID/FD and look for socket inodes. Match the inode back to the TCP table. If a connection lives in /proc/net but SS didn't show it, SS is lying, and you've just caught the rootkit. Next, the routing table, because DNS hijacks and traffic redirects hide here. Run IP route show table all. You're looking for a default route that shouldn't exist, or a rogue entry sending a specific subnet through an attacker's gateway. Then resolvectl status, check the DNS servers. If your resolver suddenly points at a public IP you don't recognize, every name lookup on this box is now attacker controlled. That's how a legit domain resolves to their C2. Let's package this into a one-shot triage script. Define net_audit, it stamps a timestamp, then dumps SS, tulnp, SS, TNP state established, IP route show table all, and resolvectl status into a bundle under /tmp. The power move, diff that output against a known good baseline you stored earlier in /etc/security/net_baseline.txt. Diff baseline live. Anything new, a fresh listener, an injected route, a changed resolver, lights up in the diff instantly. You stop hunting and start reading exceptions. For the human context, add a phone home loop. Take those established foreign IPs and run, while read IP, do dig, x $IP, hois $IP grep, I origin, done. Now each suspicious connection gets a reverse DNS name and an ASN. Suddenly that bare IP becomes hosted on a bulletproof VPS in a country you've never deployed to. That's the line that goes straight into your incident report. Capture everything, redirect the bundle to a time-stamped file, hash it, and it's a forensic artifact. Day 17 done. The takeaway: SS reads sockets, IP reads routes, /proc reads truth, and a baseline diff turns triage from guessing into reading. Subscribe for day 18, where we tap the wire with tk-dump and rotating caps.